recording so we can put this on for guys that are missing it.
Yeah, I don't think
All
Colin's
right, you guys ready to get started?
Yes,
Get done and get moving here.
Let's get
All
moving.
right. So you guys know you have to finish that quiz 8.6 and get that done. That'll wrap up section 6 for you. And then tomorrow and Friday, you can spend 2 days doing the test. As soon as you get it done, send it in. So if you finish it tomorrow, send it in tomorrow. That helps me out. So, but definitely has to be in by Friday. All right. So what we did here in chapter 8, we had the chapter review 1 to 12 all to start with. So number 1, X and Y show what? An inverse
variation.
In number 2, if Z varies jointly with X and Y, then what do you know?
It's a constant.
Z over XY. It would equal A, wouldn't it? The constant of variation.
Oh, yeah.
Okay, and number 3, this thing is called a rational function. P of X over Q of X. That's a rational function. In number 4, examples of complex fractions. That's when you have a fraction with fractions in the numerator and denominator. And then number 5, when you rewrite that equation as 3x minus 1 equals 2x, what have you done? You've multiplied. So we said anytime you have a proportion equation, you're going to cross multiply to solve. All right, so we went all the way to 12. So 6, 7, 8, 9, the variables X and Y vary inversely. So that means Y equals A over X. And if Y equals A over X, what does A equal?
XY.
X times Y. So in problem 6, the A must be 1 times 5. The A must be 5. So the equation must be Y equals 5 over X. And then you want to find Y when X is -3. You plug in -3 for X, and the Y is -5/3. In number 7, you're going to just take X times Y and get 24. Get 24 over X, and your Y is going to be -8. In number 8, you're going to multiply and get 45. So Y is 45 over X, and your Y ends up being -15. And in number 9, you're going to multiply and get -8. So Y is -8 over X, and then you're going to solve and get 8/3. So that's inverse variation. All right, section 2 was graphing the rational functions. We first had Y equals A over X, which is the hyperbola with the X and Y axis as the axes of symmetry. Then we had A over X minus H plus K.
Yeah.
And then the axes of symmetry were X equals H and Y equals K. And what do you have to not forget?
Draw the asymptotes.
When you name an asymptote, what do you have to write?
X
equals.
X equals and Y equals. I'll get you on that. Okay, so 10, 11, and 12 here, graph the function, state the domain and range. So with number 10, 4 over X minus 3, the vertical asymptote is X equals 3. The horizontal is the x-axis. It'd be y equals 0. And if the A is positive, it's in the upper right and lower left regions. That's what your graph should look like. And the domain is going to be all reals except 3. And the range is going to be all reals except 0. The values where the asymptotes are. So in number 11, you're getting 1 over x plus 5 plus 2. And so the vertical asymptote is x equals negative 5. And the horizontal asymptote is y equals 2. And so the domain is all reals except negative 5. And the range is all reals except 2. And again, the A is positive, so it's in your upper right and lower left regions, the 2 branches of the hyperbola. And then number 12 is that different type, AX plus B over CX plus D. And then we said the vertical asymptote is the x that makes the denominator 0, which is 4 here. So x equals 4. The horizontal asymptote is x equals A over C. So that would be 3 over 1. So y equals 3 is the horizontal asymptote. So again, the domain is all reals except 4, and the range is all reals except 3. And then in terms of, is it in the upper right and lower left, or upper left and lower right? You don't determine it by A now. Now you have to put a point in and see where it lands, in which region. Then you know which 2 regions you want. So what regions was that one in?
Wow,
Was it upper right and lower left?
Upper right, lower left. Yeah.
Upper right and lower left.
yes, yes.
So you just
Yeah.
throw an X in
I had it.
there and you find 1 point. And that'll tell you what your regions are. Okay, so that's 1 to 12. Then we did 19 to 35, it looks like.
Oh, yeah.
Skip section 3. You're not responsible for section 3. Okay, so in section 4, multiply and divide rational expressions. And really the first thing we did there was simplify rational expressions. You take the fraction, you factor the numerator, factor the denominator, and then cancel common factors and reduce it. That's simplifying a fraction. Multiplying is just like you have one big fraction. So you're going to factor each numerator, factor each denominator, and then look to cancel. And then multiply what's left over, and then check your answer to make sure it's reduced. So in number 19, you had monomial fractions. So you ended up with 16x cubed over y squared. In number 20, you had some factoring to do. Factor each numerator, each denominator. Cancel the common factors. You end up with 3 times the quantity x plus 4 over x plus 3.
Oh,
In number 21, it's a division. Division is multiplication by the reciprocal. Factor each numerator, each denominator, and then cancel. This one, you end up with 3x times 4x minus 1 over x minus 4 times x minus 3. Are you getting these?
Yeah.
Yep.
We're doing them, all right?
Yeah.
In number
Making sense.
22, change division to multiplication by the reciprocal, so you
Yep.
get 1 over that x squared minus 5x minus 24. Factor all three trinomials and simplify. You end up with 1 over x plus 3 quantity squared. All right? And then section 5 was adding and subtracting, which really is the most difficult of the section. Because here you have to have a common denominator. And so I went through that process of finding a common denominator. You need to factor everything, and then you take the product of every different factor. And if a factor has exponents, you take the one with the largest exponent. That gets used in the LCM. Okay, so for number 23, see the margin. Okay, margin, here we go.
Here we go.
So 23 is 3x squared plus 26x plus 36 over 6x times the quantity x plus 3. In number 24, factor and then get the LCM and then take each fraction, give it that LCM, then you have common denominators. Then you add the numerators. Then you simplify. And in 24, you end up with 5x squared minus 11x minus 9 over, in factored form, x plus 8 times x minus 3.
I had
I
that.
really prefer you give your answer in factored form, because that's telling me you're checking to see whether your answer can be reduced. Remember, you always have to do the problem, get your fractional answer, but it has to be given as a reduced fraction, which means you have to factor if it can be, to make sure it's reduced. And then number 25 was kind of a pain, is a little bit of work. It ends up being -2 times the quantity 2x squared plus 3x plus 3 over x minus 3 times x plus 3 times x plus 1. So that one was a little bit of work. How did we do with adding and subtracting?
Good.
It was good. It was good.
For
Pretty good.
most part, we're getting them.
Yep.
You got to get the couple you're going to need on the test. Okay, and then comes number section 6. And which we took it to 35. Okay, so 26, solve the equation by cross multiplying. So you just end up with 2x squared equals 18, x squared equals 9, x is plus or minus 3. 27, cross multiply, it's linear, you get 5. 28, cross multiply, it's linear, you get -3. 29, cross multiply, it's linear, you get -1. Now 30, you cross multiply, you get a quadratic. You must take that, set it equal to 0, and then factor it and solve it. And you end up with solutions of -5 and -3. And then number 31, cross multiply, you get a quadratic. Take it, set it equal to 0, factor that quadratic, and it turns out that x is a factor, and so you get 0 as a solution and -6/11. How do we do with cross multiplying?
That's simple.
That's pretty
Good.
simple, right?
Yeah, that was straightforward.
Pretty straightforward.
Okay. And now 32 to 35 solved by using the LCD. And so we said you take these equations, you look at the denominators, you find the LCD of all the denominators. You then multiply both sides of the equation by that LCD. And then you simplify. So on number 32, you're going to end up with 6. In 33, you actually end up with 0. Did you get an extraneous solution for that one?
Yes.
Yeah.
Was it -2 or 2?
Ne-
It was negative. It was -2, and that was
-2, which is extraneous. It
yeah.
makes a denominator 0, which you can't have. And then number 34, you end up with -2 and 5. They're both solutions. And then what happens in number 35?
No solution.
You get no solution. So you must have had extraneous solutions there. All right, do you feel pretty comfortable with what you're doing?
Super comfortable.
All right, we should all do very well on this test. Again, gentlemen, you're on your honor. Take the test yourself. Don't go dialing for help or whatever, phoning a
Right.
friend. So do the work yourself. Show all work so I can see what you're doing on the test. So I can give you partial credit if I need to. All right? We're all set?
Sounds
Yep.
good.
We're good?
Yep.
All right, so
Okay.
we won't meet again until Monday.
Uh-oh.
And then Monday starts the fundamental counting principle and permutations.
New material.
New material.
Yeah.
That makes sense.
And
Yeah.
we're going to keep it pretty basic. This material in class, I usually give group quizzes. So I may let you guys interact with one another in this next unit.
Ooh.
It's only about a week long.
I call Lucarelli.
We do some permutations,
I got Murray.
combinations,
I got O.
and we do some basic
Go.
probability.
I got Carlton.
But that material can get a little involved. We're going to keep it pretty basic. I think I have 1 or 2 Delta math assignments for you in that material. But, okay, let me stop the recording here.